Hi guys, this is the 10A Part 2 notes, example number 8. And the problem poses is find the sine of theta and the cosine of theta given the tan of theta equals 5/12. Again, sometimes you'll need to draw your own picture. No triangle. We always want to start these trig problems with our SOHCAHTOA, right? That's really the most helpful thing to do. SOHCAHTOA. That reminds us what each of those trig identities equals, okay? And then we're asked to find the sine of theta. So the sine of theta is going to be some ratio. And we're also asked cosine of theta, and it's going to be this ratio. But what we are given is the tan of theta. We know that the tan of theta equals 5/12, okay? And from our trig identities, we know that the tan of theta is the opposite side over the adjacent side. So this is what we know. And that gives us enough to draw our triangle. Of course, in trig, we're always working with the right triangle. So when we draw that triangle, we want to make it a right triangle. We want to also include our little square here that shows that we know, yep, this is a right triangle, okay? Then we'll use what we learned by being told that the tan of theta is 5/12 by inserting our theta. We want to put theta in, okay? So there's theta. Now we want to say, well, the opposite side to theta is 5. And so I'm going to come over here to my opposite side, and it's 5. Okay, I was a given. My adjacent side, I know, is the side that's touching theta. The one that's not my hypothesis. Hypotenuse, excuse me. Hypotenuse. So our adjacent side is 12. Okay, of course, here's our hypotenuse. And do we know what that equals? We don't. That's going to be our x. So we're going to use our handy dandy a squared plus b squared equals c squared, or leg squared plus leg squared equals hypotenuse squared. Then we'll substitute what we know. Of course, these are our legs. The sides that make up our right angle are our legs. So we know that we have 5 and 12 for the lengths of our legs. And then we don't know what our hypotenuse is. So we are going to take 5 squared plus 12 squared equals x squared. All right, that's just filling in those sides that we know from our triangle. Now, when we do this and we multiply this out, we'll get 25 plus, what's 12 times 12? Well, check yourself on your calculator. 144, still at x squared. All right, now as we simplify, we'll add these together. Now, guys, don't hesitate to come in and do your arithmetic with your calculator. That sometimes just helps us avoid making mistakes. I'm going to flip these sides, and we're going to find out that x squared is equal to 169. Of course, 169 are these two numbers added together. And in order to get our side length, we want to take the square root of both sides, and then we'll learn that x is equal to 13. Now, if you don't have your perfect squares memorized, all you can do is just put it in your calculator, take your square root. If it's an even number, yay, it's a perfect square. That's what we want to put in for that side length for our hypotenuse, 13. Okay, no more x. We know what our hypotenuse length is from using our Pythagorean theorem formula. It's 13. So when we come over here to give our trig identities, we know that the sine of theta is our opposite side over our hypotenuse. That means the opposite side from theta, that's here, that's 5. Our hypotenuse, of course, is 13. This can't simplify anymore, of course, because these both are prime. Cosine of theta is adjacent over hypotenuse, meaning 12 over 13. And that's how we do those. Thanks, guys, for watching.